Well, if you ever pull up a Perfmon, the BLG file, and you see lines like this, those two white columns, what that means is the system was so busy it could not collect Perfmon data for that time period. Now, Perfmon does run at a lower priority than most things, so yeah, it's one of the first things to go, but that typically means it's a pretty busy system. So.
You do have, yeah. You do have to be really careful though, because Perfmon will draw white lines in there. And if you just change the time frame, they disappear. So if you change in the time frame, drilling in and out, if the white lines stay there in the same place, then that. But you do have to be careful, especially at the 26 hour.
We went from 11:50 to 12:17 a.m.
26 minutes? Is that what that is?
Yeah, 26 minutes and 43 seconds. What are you thinking?
Just to be sure, click on the
this
blue monitor icon up above.
This one?
Yes. So there's, if you ever need to change the time range, that's where you would do it, to just drill into a certain area. Especially if you have like a really bad area that, you know, they captured for a couple of hours and you've got a 10-minute period you want to show them, you might just go 5 minutes on either side of the 10-minute and zoom in.
Yes.
To show them specifically. But have it to the right of that white line a little bit. Should we say okay? Okay. And the white line still shows up.
So it's legit.
Yeah. But be careful, because I've pointed those out before, and when you change the scale, they disappear.
Cool. So what I did was I just double-clicked on the VLG file, and of course it pulled up every darn counter that we collect. So I'm going to remove them all, but I'm still pointing to the VLG file in the background. So the way to do that is you say file, not there. If you open up Perfmon, and you can click here, right click on it and go to properties. You go to source and you can indicate the BLG file you want to look at. So you just go find your file and double click on it. But we already have one open. So the counters, and Todd will interject because everybody has their preferences and things they like to look at. But for SQL Server, if you want to look at the disk, you have reason to suspect maybe there's a problem with storage being slow or something. You want to look at physical, not logical. And the counters I grab is average disk seconds per transfer. And I want to grab all instances and say add. And I also want the disk bytes per second. There's some other counters I like to grab. If I'm in the Perfmon anyway, I might as well look at these two. So memory available bytes, just to make sure we're not really low on that. And go down to the SQL stuff. Buffer manager. You can look at the buffer cache hit ratio. Lazy writes per second. And I'll go into what each of these things are. Page life expectancy. Memory manager. And we're going to get the bottom two, which are target server memory and total server memory. And another good one I like to look at is the plan cache. the cache hit ratio, and I usually say all instances. We also probably want to look at processor, and these are in alphabetical order, so processor, percent privilege time, and percent user time. Oh, total. I don't care about each individual CPU. User priority. Okay. Dun dun dun. Okay. Wow. That kind of looks interesting. We've got a whole bunch of stuff at the beginning, and then things kind of look different. So available megabytes. So this is how much memory is left for the system to use, meaning like the operating system and stuff like that. Down at in this middle part here, oops. So this is the last value that was recorded. This is the average over the time that we've collected, and this is the lowest it got. This is the highest it got. So what does this value mean? This is megabytes. So what is 95,730? 95 gig, roughly. Yep. That's plenty of available memory. We don't want to get below, well, 300 would be the like totally bottom, the lowest. But if it's 500 meg, I still like, man, we're cutting it close. Okay. Average disk seconds per transfer. So when we look at disks, the first thing we have to do is we have to establish whether or not there's latency. Okay, so by looking at average disk seconds per transfer, we're trying to determine if there is latency or not. We want to look at the average value, but we want to consider too the maximum in some situations. Okay, the average ideal values for average disk seconds per transfer is going to be between 10 and 15 milliseconds. So that means this value right here is going to be 0.010 or 0.015 or lower. So we're 0.004. Beautiful. That's a good one. The maximum also right there. So good. And you just check each of the disks. So this is 0.001. Great. That's wonderful. C. We're starting to see some stuff here, but this can be deceiving because it could be not to scale. We have 0.005. Now we had a maximum of 0.099. That would be some latency, but we want to consider the average. Spikes are okay as long as they're not sustained, and also depending on how many megabytes per second we were pushing to the disk. Disk 6. Ooh. So right here our average is 0.021. That's more than 0.015. 21, that's starting to get concerning. If it's 0.030 or more, there's definitely latency for sure. And look at our maximum over here. That's almost a third of a second, or that is a third of a second that we're waiting for the disk to do some stuff. So we have a nice latency here on 6. So what I want to look at next is the disk bytes per second for that drive that definitely has latency. And what I'm trying to figure out is the disk latency because SQL is flooding the disk with too much data, or is it something up with the disk subsystem? My maximum value over here for megabytes or bytes per second was 27 meg. Okay? That's not a lot of data, right? For a SAN, we expect disks to easily handle 150 or more megabytes per second with no latency. A disk drive in a typical PC, with a SATA drive, those can handle 60 to 75 megabytes per second with no latency. So 27 meg is not much data, and that's, significant latency. So I would say to this customer, you probably need to have your storage system checked out by your storage vendor. Now, this will take some time for you to get comfortable with, but just the breakdown is there latency? Look at the average disk seconds per transfer. If there's no latency, then don't look at any other disk counters. It's pointless. If there is latency, then you want to look at the bytes per second. Any questions on that?
Can you repeat that, please? Sorry.
Sure. So we want to check and see if there is latency with average disk seconds per transfer. If there is no latency, then we don't need to check any other disk counters. If there is latency, we want to check the bytes per second. If the bytes per second is low, something's wrong with storage. If it's high, we're flooding the disk. So if this value was high and SQL's flooding the disk with too much data, what do you think we need to do to fix that?
See what queries are causing that much
Yeah.
redirecting to this.
Yeah. So maybe we have a inefficient query.
Backups and new storage, maybe jobs, stuff that's like right. It's a question.
Memory contention, maybe something that's having to write to this block that's running all memory.
Indexing.
Indexes, yeah. If you've got, you're running low on memory, what's it got to do? It can't find the stuff in memory, so it's got to go to the disk to retrieve the data. Yep. Certainly. What else is hitting the disk? Backups, maybe other applications. So that's a good point. We need to check and see what is driving this disk activity, right? We can check that from process. So under process, there is I/O data bytes per second. And you would go pick SQL Server. And add. It's going to add it to the bottom. So SQL Server 11 meg. So it's driving some of it, but not all of it. And that was just one drive that we were looking at. So there's probably something else hitting the disk here. I want to check, what other applications are running. Missing indexes, what else could cause excessive disk activity? When people say performance is slow in SQL, what's the number one thing that should come to your mind? Statistics, yes. How are our stats? Anything else, Todd, that could drive that? Todd?
What?
Anything else that could drive disk activity?
Somebody watching a video with the disk file on that drive on that server. You already answered that one.
Yeah, we said the other things running on there, yeah.
I was trying to look, somewhere I saw a picture one time that shows the different layers where Perfmon gets physical and logical disk. So I was deep in thought trying to look for that.
That's all right.
They're only slightly off, so as far as the counter you get, doesn't really matter between physical and logical.
Okay. Good to
What was the
know.
question again?
The things that can drive disk activity. So we've already identified missing indexes, statistics, inefficient query, Other applications, low memory.
I think you guys would get it, but it could be a legitimate query where somebody's running a report. The end of month report is running, so still don't jump to think that something is wrong, or at least if you're on the call with the customer, oh, this disk is being slammed, there's something wrong. Not necessarily, because if their report that they're running has to scan the entire table for all the month of March sales or whatever to build the report, it could still be just legit. You just have to read the disk that much.
True.
You don't want to get caught telling them it's a problem, that something's broken or something's not right, and then in the end, it's just like, oh, we rerun a report. Oh, okay.
Yeah.
Isn't that something they would encounter often though? I mean, reports generally, they run them at the end of the month anyway.
It depends. No, that's not something you run into a lot. Some customers, but I wouldn't say that would be typical. Ideally, you would pull your reports off to a different system, right? You wouldn't be running that against your same production system, alongside OLTP.
Now, what happens if this is like an Azure customer? If you came across like something where it's like, this looks like it's potentially a problem with this, then it's like transfer this to, is there a team that handles performance problems with Azure?
Yeah, we do. So in Azure, the disks are our disks, right? We supply everything. So you can't turn around and say, yeah, something's wrong with your storage. You need to contact your storage vendor because, okay, we're going to turn around and contact ourselves. The threshold is higher in Azure. Okay, so instead of it being 0.30 for sure something's wrong, it's 0.50. Also, there's things they can do. You need to make sure that they're adhering to best practices. They've got multiple disks. They're the P30 disks, which are premium storage. Think more money. And if they're not configured that way, we tell them to change their configuration to comply. If there is still excessive disk latency with that, then yeah, there is a Azure storage team that we would cut a problem to, and they would check it out from their side. But rare is that. So disks. Oh, somebody's got a message. Oh, yay. Okay. Let's see.
A purpose of the point we was making, shouldn't we been looking at a longer time span to see whether that's a continuous problem? It's a snapshot of about 20 minutes or so. So wouldn't it make sense, maybe let's look at it for 24, 36 hours, whatever?
No, you don't want to gather that much data. No. So what happens when you have an average, okay, and you're trying to calculate an average over a set of time, and there's no activity, then we run this one report for 15 minutes, and then it drops back down. If you take your capture over that long time period, your average is going to shrink, right? Because it's over that time. And they're saying, no, while we run this one report, it's taking longer than it used to, or we see a lot of disk activity. So you would want to, maybe you've got a longer PSSDIAG or Perfmon, but you would want to shrink it down, like Todd was saying, to just that time frame when they experienced the issue, so that you could see the true latency or the problem during that time frame. And it won't get skewed by the non-activity time. Does that make sense? Yeah. Plus, you don't want to sort through a big O file like that anyway, for 24 hours or something. Maybe for baselining, but for troubleshooting a specific thing, I would say no. All right. So CPU, there's a difference between user time and priority time. What do y'all think the difference is?
scheduling maybe? Like priority scheduling with like threads that are being scheduled, and all that sort
Okay.
Maybe like prioritize anything not SQL.
Mm,
Users like
kinda. I mean, that's true, and yours is true too, parts of it.
sort of like a wait time, like where it's not.
Mm.
You know, the term kernel,
of. Oh,
kernel mode.
Okay.
So priority would be the operating system stuff, kernel, going down to that layer. User is your applications, everything that's in the user mode. So not only SQL, but all the other apps. Okay. If the priority time percentage is really high, what do you think that might indicate?
OS related issues.
Yeah. Well, could be more specific, maybe.
I don't know. Are you running Windows updates right now while this is running? I'm trying to think of.
Could be a driver, a bad driver. Could be encryption. So if your SQL instance, you have TDE enabled, you can expect to see a little bit higher priority time for those kinds of cases. User time, yeah, you'd want to check if it is high, make sure it's SQL that's driving that CPU. It might be something else. What affects CPU in SQL as far as performance? We just talked about this last week, I think.
IO.
IO, yeah, reads will increase the CPU.
Anything SQL's doing.
But what about purely CPU?
Mathematical calculations.
Mathematical calculations. And then there's some SQL stuff that we do.
As far as like query optimizations or
Plans.
If you have missing indexes, you're going to have higher CPU. Plans, compiling, recompiling plans. What were you saying?
query optimizations.
Yes. Inefficient queries. What's another one? The number one thing we check whenever there's a performance issue?
Stats.
Stats. Another thing is if your queries are doing a lot of data conversion, like data type conversion. Yes. All right. Buffer cache hit ratio. What do y'all think that means? Huh?
What do you think it means?
What do you think the buffer cache hit ratio means? Why are we interested in this counter?
How many times it was able to pull something, the ratio of times where it's able to get whatever it is from the buffer cache versus where it has to go to this?
Yes. Yes. So this is, I'm able to get the stuff from the buffer cache. What's the buffer cache?
The information it stores in them.
Yes. Yes. How does it store it? And what increments?
Pages.
Pages. How big are those pages? 8K pages. What do we call 8K pages?
64.
You are correct. What else do we call it? Extent for 500, yes. Or you should have answered, what is 500, or what is extent, right? Yes. So this is the buffer cache hit ratio. We want it to be high. However, if you see that it's like the little dips into 80 or something like that, don't ever go by one single counter to say, oh, there's a problem, right? So we look at the buffer cache hit ratio, and that's interesting if there is a dip. Now this 95 is the minimum, this is not a problem. It's not interesting. This one kind of goes hand in hand with the buffer cache hit ratio, which is lazy writes. It's kind of a deceiving name, but does anybody know what lazy writes are?
Yeah, you said this before. You can't.
Isn't it something with it not being able to track the entire other process? Like it just basically is dumping it and then not bothering to confirm its completion.
Not really. Dumping, yes, kind of dumping.
Like checking one's transaction log.
No. Okay, so the buffer cache, so when SQL goes to do stuff or retrieve data, it looks in the buffer cache, and it has to get pages from the buffer cache to do its work. If those pages, if there's not any available, they're all used, then SQL has to get LazyWriter to write some of those pages, the dirty pages, to disk in order to free up those pages for SQL to do its thing. Okay. Normally, dirty pages are written to disk by checkpoint. That's what checkpoint does, and it does it with some regularity. I don't know what the algorithm is, but whenever SQL feels like it needs to do a checkpoint, it does a checkpoint. This is over and above what the checkpoint is doing. So it indicates internal memory pressure. Think of it like SQL is internally paging. It's having to, I got to write this to disk in order to free up the pages to do this other thing over here that I've been asked to do. Right? So if you see any lazy writes, that indicates memory pressure. Now, if you only see one little one, you have to take into consideration the whole thing, right? Don't go by any one counter. Page life expectancy. So these three, buffer cache hit ratio, lazy writes per second, page life expectancy, they all are kind of related. What do we think page life expectancy is?
That's how long something stays in memory before it gets booted out to next space or something else.
Yes, exactly. So this is how long a page lives in the buffer cache. What is a good value, or what is if we dip below X, there is an issue.
I think 500 seconds was the value.
500.
5 minutes, rather.
5 minutes. So what would 5 minutes be? People are frantically doing math. 300. 300. That's what we stand by, and we kind of go by. Now, that's not hard and fast rule. If you've got a very large system with a lot of memory, 300 is not a lot of time. That's pretty low. So if you search for this online, you just say page life expectancy counter value. There is all kinds of SQL people arguing how 300 is just not a good measurement to go by. It should be higher than that, and da 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 da. So, but that's our bottom, and if it's at least 300, okay, you're okay. And I don't mean like for the high. That's like that should be the lowest it would ever go. Anything you have to say about that, Todd?
That's, it's like we got to start with a number somewhere. So that's our general number. But like she's saying, if you've got, if that machine has 256 gig of RAM, and they went through that many pages in 5 minutes, I'm kind of like, what's going on there compared to if it was 16 gig of RAM or something. So the amount of RAM is totally relevant. Just like she's mentioned before, maybe none of these counters alone is enough to tell you there's an issue, or what the issue is necessarily. And that would be one where it's like, you need to keep the counters in mind. And I was thinking with even like the buffer cache hit ratio, somebody could have a system where the numbers look horrible, because they've got fast disks and they just happen to be running queries that are always having to go to disk, but they don't have a disk perf issue. We can point it out, but don't jump on that is the, none of these, except maybe just average disk seconds for transfer. When those numbers are off, then that's a big red flag and go look. But a lot of these other numbers depend on the case, and check out the other numbers as well to help decide if it's we should search screen without it.
Yep. Usually if the numbers are not within the ideal, it just means you need to investigate further. It's not conclusive, you know, that, yeah, there's something wrong. Except for, like I said, average disk second for transfer. Target server memory and total server memory. These are related. Does anybody know what target server memory relates to?
So target server memory is going to be what you basically told SQL Server you want to have as its maximum memory, and total server memory is going to be what's actually utilizing.
Yes.
If you see your target server memory bar moving, that's not a straight line like it is there, then you have a problem because SQL's trying to get probably get more memory than it's been told it has, or doesn't have enough.
So it starts trying to take some of Windows